As built for AutoCAD Tutorial Oriented Images. Part 3 of 3, Facade Plan. After this tutorial, you will be able to load oriented images, prepare viewports, create a facade UCS, user coordinate system, derive 3D geometry from photos, and flatten geometry to a facade plan. Notice, please watch As Built for AutoCAD Tutorial Oriented Images Part 1 and 2 first. For a detailed description of every command, please refer to the user manual. For demonstration purposes, we will speed the video up in certain areas. If significant changes are made, we will review them and resume the video speed. Start with an empty drawing. Ensure that you have several layers created with specific colors and line thickness of at least 0.3. Make the Photos layer the current layer for the images we want to import. You can now use the oriented images you manually oriented in Part 1 of this tutorial series, or use those we imported from the PhotoScan project we imported in Part 2. Go to As Built Photo tab. Start Image Management. Go to the Settings tab and click the ellipsis, and browse to the subdirectory we created in the previous tutorial. Switch back to the oriented images, and here you will see all the images. You can also load the images that you oriented manually in tutorial part 1. In the Oriented Images group, click the Load command and browse to the folder where you saved the data. Select both images and click Open. We see the two oriented photos symbolized as small pyramids. The red lines are pointing to the center of projection, tip of the pyramid. It is equivalent to the position of the camera during the capture of the photo. The pyramid also illustrates the direction of view. Let's create the viewports for our image evaluation. Open Image Management. Go to the Settings tab and deselect the folder. Switch back to the oriented images, and here you will see the two images we will work with. We will create two viewports. Click the right chevrons to open the Viewports dialog and click to Vertical. Click OK. The left viewport will be for the oriented images and the right viewport to view the 3D geometry. To hide the images in the right viewport, select it and switch its properties to large and then back to none. Thus, the view of the resulting geometry is not obstructed. To prepare the left viewport, select it and change its properties to large. Double-click DSC_0028 image to load it to the left viewport and enable the camera navigation mode. Let's derive a 3D geometry from the oriented photos. Click the Home tab. Switch the layer to the blue Layer 2. Go back to the As Built Photo tab. Select the Image Management Settings tab and view the options. Since we are working only with two images, disable the option when swapping unload the image previously shown in the viewport. Select Image Evaluation with two images. It makes the evaluation faster. You can turn the epipolar line off or on. Keep it turned on. In addition, you can change the color of the epipolar line in case the default yellow is hard to see on your photos. Click Cancel. Go back to the Oriented Image tab. To create the facade plan, we need to define our user coordinate system and place it on the main facade. Go to the As Built Modeler tab. From the Modeling group, select the Fit Plane command. Pick the option Points from Multiple Oriented Images. The command prompt asks us to specify a point on an oriented image. Zoom into the image and pick the first point in this window frame as shown here. Double-click the second image and zoom in. Notice the epipolar line, which helps you to find the corresponding point on the image. It lies on this line. Now that the point for the plane is defined, we can click the second point on the window. Continue this process between the images until you have a minimum of 3 points for the plane. For this example, we will pick 6 points. If the picked point is way off, you will get this warning. You can either accept the point as is or click No and pick the point again. Continue the process. Once you have the 6 points, press Enter to finish the process. This will take you back to the Fit Plane screen. Here, We can see the mean distance and the max distance. Looks like we have a good max distance of 4 millimeters from the average plane. We can also define the plane to be perpendicular to the XY plane of the user coordinate system. This changes the statistics a bit. Name the plane Facade and click OK. Click in the right viewport and double-click the mouse wheel to view the facade plane. Switch the user coordinate system to the plane. Switch to the top view. Type Plan in the command line and press Enter. Turn off the layer Cubit plane. Ensure Layer 2, blue, is current. Now we can start drawing on top of the user coordinate system. With a definition of the user coordinate system, we do not have to pick 2 points in each image for the next geometry we draw. We can just use one image. Let's draw the outer frame of this facade. On the Home tab, select the Rectangle command. Pick a point on the upper left corner and drag it down until you reach the lower right corner and pick a point there. Enable the line weight to have a better view of the line. Notice how the geometry shows in front of the image. The same principle applies to the geometry of the windows. Select Layer 1 to draw them on a different layer. Again, select the Rectangle command and pick the 2 points on each corner. Press Enter to restart the command and draw the other window. Continue with the process. Now we will draw the frame and the windows on the parallel facade plane. To do so, we need to switch the UCS to this parallel plane. Go back to the As-Built Photo tab, and in the Image Modeling area, select the Set Evaluation related to the UCS XY plane command. We need to pick one point in the plane, and it needs to be done in both images. Be sure to pick a point that is visible in both images. Pick a point on the upper left corner. Switch the image and pick the same point. Switch back to the other image. Now this plane is our drawing plane. Switch back to Layer 2 and select the Rectangle command. Pick a point on the upper right corner and drag it down until you reach the lower left corner and pick a point there. Select Layer 1 to draw the window's frames. Again, select the Rectangle command and pick 2 points in each corner. Press Enter to restart the command and draw the other window. You can use the Arc command to draw arcs. On the right viewport, you can see the geometry developing. Continue with the process. Use Orbit on the right viewport and see the geometry created in 3D on the correct plane. Switch back to the plan view. Type Plan and press Enter. We can continue drawing the frames that are a bit further in front. Go back to the As-Built Photo tab, and in the Image Modeling group, select the Set Elevation related to the UCS XY plane command. We need to pick one point in the plane, and it needs to be done in both images. Be sure to pick a point that is visible in both images. Pick a point on this mark, switch the image, and pick the same point. Switch back to the other image. Now this plane is our drawing plane. Switch back to Layer 2 and select the Rectangle command. Pick a point on the upper left corner and drag it down until you reach the lower right corner and pick a point there. Repeat on the other side. With the same process, you can create a model of the entire facade. Once everything is completed, you can flatten the drawing to create the facade plan. To start, click the right chevrons, click Yes. This opens the Viewports dialog. Switch to Single and click OK. Type Plan to switch to the plan view. Let's detach the images from the drawing. Type XREF to open the External Reference Manager. Select both images, right-click, and select Detach. Go to the As-Built Modeler tab and select the Flatten command. To define the Z value, you can either type or pick a value from the drawing. For this example, we will pick a value from the image. Click the corner of the window frame to flatten to this facade plane. Ensure that the options in Object Selection are deselected. We only want to flatten the objects that are currently visible. Click Select Objects. Click and drag to select all of them and press Enter to confirm. If we had text, we could include it to the flatten process, but that's not our case. Keep the settings as seen here. Here you can see the number of objects selected. Click OK. Now everything has been flattened to one facade plan. We can add annotations using native AutoCAD. Click the Home tab, select Layer 0, and in the Annotation group select the Linear option. With the Object Snap-On, you can annotate the width of the windows. Press F3 to turn the Object Snap on or off. If the annotation is a bit large, change the style. Click Annotations, Dimension Style, and Modify. On the Fit tab, reduce the overall scale. Click OK and close. You can continue annotating using native AutoCAD, or you can use the As-Built Dimensions options. When you select the Reference Height command, you can choose the look of the symbol or add more information. Click OK. With Object Snap On, click the point at the bottom of the blue frame to define the reference height and place the symbol. You can add height dimensions that are related to the reference height. Again, you can change the format. Check the Repeated Insertion option if you need to add multiple data. Click OK and place the height dimension symbols. In this tutorial, you learned how to load oriented images. Prepare viewports. Create a facade UCS, User Coordinate System. Derive 3D geometry from photos, and flatten geometry to a facade plan.